This is actually in this video we are going to see continuous memory allocation. Write a C program or Python program to simulate the following continuous memory allocation techniques of worst fit and best fit and first fit. Let's get into the code. This is the best fit. First we have defined here a number of process is equal to int of enter the number of process that we need to give by the user, and n is equal to number of process and block number and block size and process size and allocation is equal to minus 1 into n, and we are using the for loop for I in the range of n, block number of append I plus 1, and the block size is equal to int of input enter the block size of plus p a string of I plus 1, and the block size size 1 dot append of block size, and for I in the range of n minus 1. Process size is equal to int of int enter the process size plus p plus string of I plus 1, and the process size 1 dot append is equal to, append of process size, and we are giving the print block number and the print process size 1 and the print block size 1 for I in the range of length of process size 1, for j in the range of length of block size 1 if block size of j less than or equal to greater than or equal to process size of I, and we are using the elif block of size and bst idx less than greater than block size of j if bsl is decrementing. For we are giving the print of process size and block number for I in the range of length of process of size 1 and print I plus 1 and process size, and if allocation of I equal to decremented, print allocation of I plus 1, else print not allocated. Let's run this, and we are going to enter the process 3. And process 1 is we will give as a 100, 900 and 200, and the process size is will give 111, 345, and this is the output for the best fit. And now we are going to see in the next is a first fit. We are giving a number of processes is equal to int of int enter the process, and n equal to number of process block number and block size 1 and process size 1, allocation is equal to minus 1 into n, and for same as for I in the range of n, and block number dot append of I plus 1 and block size is equal to int of int enter the block size plus string and block size 1 dot append of block size, and same as last one for I in the range of n minus 1, process size is equal to int of int enter the process of size plus string of I plus 1 and process size 1 dot append of process size, and print block number and print process size and print block size 1 for I in the range of length process of size 1, for j in the range length of block size 1 if block size j is less than equal to process of size 1, allocation of I is equal to j, blocks of j is equal to 0 and break, and else you need to allocation of minus 1, and we are printing the allocation of print of process size and block number for I in the range of length of process of size 1, and print p I plus 1 process size if allocation of I is decrementing, and print allocation of I plus 1, and else print is not allocated. Let's run this, enter the process here 3, and the block size will give as a 400, 600 and 300, and the process is will give 999, 34, 666, and this is the output, and it shows as a not allocated. And next, and as a worst fit, same as and we will be assigning a number of processes equal to int of int and enter the process that should give, and enter the in is equal to number of process and a block number, block size, process size, and a location. For I in the range of n, block number of append I plus 1, and block size is equal to int of int, enter the block size for pick and string, and block size of 1 dot append of block size. For I in the range of n minus 1, process size is equal to int of int, enter the process size, and process size 1 dot append process size, and print block number and print process size 1, print block size 1. For I in the range of length of process size 1, for j in the range of length of block size 1, if block size j less than or equal to, greater than or equal to process size 1, if the block size of less than block size, and it will show here if WSTID is decrementing and allocation of I is equal to WSID and block size of is equal to 0, and it is going to print the process size and block number for I j in the range of length of process size, and it should be print as a print I plus 1 process size, and if we allocated no decrementing, and print allocation of I plus 1, else print is not allocated. Let's run this. We are going to enter the process. We are going to process a 3. We will give here as a 300, 5, and 7. And we are entering the process 444, 6, 5, 7, and it shows the block number 3 and not allocated. That's it.